Good day everyone and welcome to Mojoptics. Today we're going to invent a digital sundial. Go! Alright, so we will need an empty jar, a few bolts and nuts, and we'll also need a 3D printer. Now, I know that not everyone has a 3D printer, but I've still got you covered. I'll put a few kits with all the 3D printed parts on the Mojoptics gift shop, so that in the end, everyone should still be able to build their very own digital sundial. Alright, so sundials. Right, so you can find sundials pretty much all over the planet and in all shapes and sizes, but they actually all work pretty much exactly the same way. So you have some sort of elongated thingy that will cast a shadow onto a surface, and then you just have to read the tiny numbers on that surface right next to the shadow to know what the time actually is. So in the end, basically it's not very different from actually reading the time on an enormous analog watch. Now, what if we actually had a sundial that worked a bit more like some sort of enormous digital watch? Yeah, visually it would look a little bit like this. And that's what we're going to invent today. So we know what we want. Basically something that will cast a shadow with the time written inside. But we still don't really know what this something should actually look like. So we're going to design an object, the sundial, based on its shadow. So basically it will all be a very fancy shadow puppet show in 3 dimensions. Now prepare yourself for the eureka moment. Ta-da! We've just invented a programmable pixel inside a shadow. So now it should be much easier to invent our digital sundial, because if we can switch on and off one pixel, then we should be able to switch on and off heaps of pixels. Alright, so the first step is to take all the numbers we want to display and slice them into really small pixels, so that when we will want to display the time, then it will just be a matter of switching on and off a whole bunch of pixels, which is something we know how to do now. Second step is to decide what times we want our sundial to display. So let's say, for example, from 1000 up until 1600 every 20 minutes. And last point, we need to know where the sun will be in the sky during the day. Because every single time we want to switch on a pixel, we need actually to know in which direction we should be digging the tiny tunnel. Okay, so the Earth is round, well, more or less. So the ground level in Switzerland is basically much more tilted than the ground level at the North Pole. Or in other words, for penguins at the North Pole, the sun would be much closer to the horizon than it would be for cows in Switzerland. This might actually be a small problem for us, because it would seem that if we design a sundial to work in Switzerland, then that sundial will actually not work at the North Pole. And it will probably not work in Germany or Italy either. However, there is a small trick that we can use, and that should allow us to use the same sundial all over the planet with only a small modification. And it's really not rocket surgery. We just have to look at things from a slightly different point of view. Alright, so first, try to visualize the latitude and longitude lines over the Earth. Then just inflate these lines up until they reach the Sun. Now, when the Earth rotates, we can actually see the Sun moving on that big sphere. More precisely, we can actually see the Sun moving along one of the latitude lines. This actually means that we see the Sun rotating around the Earth's rotation axis. So here is the trick. Wherever we are on the planet, we will tilt our sundial to always be oriented along the Earth's rotation axis. This way, the Sun will simply describe a circle around the sundial. So, for example, at the North Pole, our sundial will be vertical with respect to the ground. And in Switzerland, you will tilt the sundial such that the angle between the ground and the sundial is about 47 degrees, with the tip of the sundial pointing towards the North Pole. Alright, so in practice, this means that we will simply need to design some sort of hinge mechanism to adjust the tilt of the magical black box. And then our sundial should work pretty much anywhere on the planet. Now, let's move on to actually designing the sundial. So, throughout the day, we'll have to switch on and off really a lot of pixels. That means that we will have to dig really a lot of tiny tunnels inside the sundial. Now, we could use some random 3D modeling software, start with the black box, and then one by one design each and every one of the tiny tunnels inside this box. But it would take ages. It would be so much nicer if we could somehow automate this whole process. Now, turns out there is actually a really cool 3D modeling software called OpenSCAD that can do just that. Alright, so OpenSCAD. It's free, it's really easy to use, and it's extremely popular. So there are already a lot of tutorials, guides and examples on the interweb. And it has a distinguishing feature compared to most other 3D modeling softwares. Instead of drawing stuff with your mouse directly on your computer screen, you actually write down small scripts in which you describe what you want to model. So it may sound a little bit intimidating at first sight, but it's actually very easy to use. What you see right now are all the words you can use in a script. That's it. You don't need to know anything else. So, for example, let's say you want a cube with a round hole inside. So you write down in your script that you want a cube with the proper dimensions and at the right location. You also want a cylinder, again with the proper dimensions and at the right location. And then you simply write down that you want to subtract one from the other. Et voilà, a cube with a round hole inside. One of the really cool things with this approach is that we can write down in a script some sort of cooking recipe for a tiny tunnel, in which you basically describe how you would dig just one single teeny tunnel inside the black box. As you can see, you only need a few lines of code. Right, and then you tell OpenSCAD to use this cooking recipe over and over again for each and every one of the pixels you want to switch on. And again, it's only a few lines of code. Then the rest of the script is just describing the shape of each of the components and also telling OpenSCAD where you want to display the time inside the shadow. So it's mostly artistic in nature actually. Right, so the script is maybe a bit long, but really there is nothing technically difficult inside. Okay, so this is how the 3D model looks. So you have the magical black box. It is this component that will actually display the time inside its shadow. Here there is a hinge mechanism to rotate the magical black box. Okay. This way you can adjust precisely the time. Another hinge mechanism here to tilt the black box. And this angle here should be equal to your latitude. And finally, with this component you can screw directly the sundial on top of a jar. Then we'll just have to orient the sundial to have the tip of the sundial pointing toward the north, if we are in the northern hemisphere. Ta-da! We are now officially mnemonists. Basically, a mnemonist is a designer of sundials. And as soon as we have built our sundial, then we'll also become dialists. And basically, a dialist is a maker of sundials. Alright, so we've already seen that the structure inside the sundial is a really complicated Swiss cheese. So realistically, I'd say that the only practical way to build this sundial will be with a 3D printer. So let's go! Alright, so it takes about 35 hours to 3D print everything. The magic black box alone will take already more than 20 hours of continuous printing. Everything is open source, so if you just follow the link in the blog, just below this video, you should find all the files that you might need to 3D print this sundial. I've already printed quite a few of these sundials, so here is my advice if you would like to try it for yourself. Right, so first use ABS plastic. As you probably already know, the two most common plastics used for 3D printing are ABS and PLA. PLA is usually easier to print, but it has a few drawbacks. One of them is that it has a tendency to slowly deform under moderate heat, such as, for example, when you leave it for a long time under the sun, which might be a bit of an issue for a sundial. Then secondly, the printing resolution. So with most 3D printers, you can choose the thickness of the layers you want to print. It's always a compromise between resolution and printing time. So for the magic black box, I would advise to use 0.1mm layers. I know it is very high resolution and it will take almost a full day to 3D print it, but it's really worth it. Because with a coarser resolution, you won't be able to print the very fine details of the Swiss cheese inside the black box. And your sundial will have some very annoying displaying errors. So use layers with a 0.1mm thickness. For the other components, you don't really need such high resolution. So for example, 0.15mm is just fine. Alright, so this is how it looks. So we have the magical black box right here. That's the component that will cast a shadow with the time written inside. And as you can see, it's a really fancy and complicated Swiss cheese inside. So we can rotate it like this to adjust precisely the time. So we can even actually adjust for daylight saving time, which is pretty cool. We can rotate it around this point here, like this, so that we can adjust this angle as a function of the latitude. And then we also have a glass jar here. So you'll want actually to fill this jar with something a bit heavy to stabilize everything. I used a whole bunch of pennies, but I guess you could use pretty much anything you like, such as sand or even Vegemite, if you have some. Alright, so now we can actually go outside into the wilderness and test it for real. Ooh, works! Alright, so we have invented a sundial that can display the time with actual numbers. We become mnemonists and dialists, so I'd say it's been a rather productive first episode. Now, if you'd like to support this podcast, or simply if you don't have a 3D printer but still want to build your very own digital sundial, then go to the gift shop on mojoptics.com. I will prepare a few DIY kits with everything inside. So all the 3D printed parts, printed with my very own 3D printer, the glass jar, and all the bolts and nuts needed to assemble everything. If you have any comments, suggestions or ideas, there is the website, wafwafwaf.mojoptics.com, the Twitter @mojoptics, and my email address, julesdozer@mojoptics.com. See you soon.